Okay, so in this video, we're going to be reviewing scientific notation. Scientific notation is a way to write large or small numbers in a more condensed way. In scientific notation, a number A is between 1 and 10, and then times 10 to B, which is the power to which you multiply by 10. B is going to be positive for large numbers and negative for small numbers. For example, the speed of light is 3.00 times 10 to the 8th meters per second, where the universal gravitational constant is actually a very small number. It is 6.67 times 10 to the negative 11. Okay, so positive B for big numbers, negative B for small numbers. So let's look at some examples of converting between regular notation and scientific notation. So, say in regular notation, I have the number 0.002. In order to convert that to scientific notation, I have to move the decimal so that I have a number in between 1 and 10. So I'm going to put it there after the 2. In order to get it there, I had to move it 1, 2, 3 times. So that means that in scientific notation, the number is 2 times 10 to the negative 3. It's a small number, so it's negative. Say we're going the other way. I have a number like 4.5 times 10 to the negative 5. Okay, negative 5 means that it's a small number, so I'm going to be moving my decimal to the left 5 times. So it goes 1, 2, 3, 4, 5. The decimal point's going to go there. These empty spots get filled in with zeros. So I have 0.00045. Okay, let's look at another one. 780,000. Okay, if I was doing this in scientific notation, I would put the decimal right there. It doesn't have a decimal in it, so we assume it's at the end. To get it there, I would have to move it 1, 2, 3, 4, 5 times. 7.8 times 10 to the 5th. One more example, 6.21 times 10 to the 3rd. I would move the decimal 1, 2, 3 times and get 6,210. In a lot of classes, you have to do calculations where the numbers are in scientific notation. So it helps to know how to plug this into your calculator. There's a lot of different buttons for this. It's not standardized on all calculators. You might have EE, EXP, or at times 10 to the X, or times 10 to the N. Those are all buttons that I've seen on calculators. So, say I was plugging this into my calculator. 8.7 times 10 to the 5th plus 3.23 times 10 to the negative 2. Okay, I want to add up those two numbers. I'm going to show you how to do it on two different calculators. Okay, first, this button has the EE. Okay, so if I look at my number, it would be 8.7 times 10 to the 5th, plus, sorry, what was the other number? 3.23 EE, which means times 10 to the 2nd. And I get that number, 870,323. On this calculator, 8.7, it has the EXP button. And that takes me up over here. So 8.7 times 10 to the 5th plus 3.23 times 10 to the 2nd, and it gives me that number right there. A lot of calculators, you can change the mode. If you ever see SCI, that's scientific mode, so it will actually give you the number in scientific notation. So Again, our answer here, since we only had 2 sig figs in each of these, we would want to report the answer only to 2 sig figs. So I would keep it at 8.7 times 10 to the 5th. 8.7 times 10 to the 5th is so much larger than 3.23 times 10 to the 2nd that it doesn't really make a difference. Okay, let's look at a more complicated example. This is a problem that you might see when learning about the calculating the gravity between 2 different masses. Okay, so I'm going to show you on the TI-30X. If it'll come up here. Where did it go? There we go. Let me pull back up the problem. Hopefully I can edit this. Okay, it's going to have to be good enough. 6.67. I'm going to put all the top in parentheses. So 6.67 times 10 to the negative 11 times 3.23 e, which means that times 10 to the 24th times 243, all divided by 1.23 times 10 to the third. And it gives me my answer in scientific notation. Again, you always go by the least significant. So since all these numbers only had 3 digits, I'm going to keep my answer to just 3 digits. And I will then report my answer as 4.26 times 10 to the 13th. Okay. When plugging it onto the calculator, most calculators, if you use one of these 3 buttons, you do not have to type times or 10 or to the. It's all included in that one button because this is so common. And again, if you can put your calculator in Sci mode, that'll give you all of your answers in scientific notation. If you don't have a calculator for whatever reason, there are rules you can follow to do simple scientific notation math in your head. When you're doing addition and subtraction, as long as the powers of 10 are equal to each other, you can just add the numbers. So if I look at this example right here, okay, first I need to make the powers equal to each other. I can either take this 10 down or raise this 10 up. I'm going to choose to take this one down. So I'm going to move some of those powers of 10 into this number. So if I have 87 times 10 to the 4th, that's taking one of the 10s out of this value and putting it in here. I need to go even further. So 870 times 10 to the 3rd. I want to get all the way to 10 to the 2nd. So it's 8,700 times 10 to the 2nd. Okay. So that is one option. Once I have it in that mode, I can simply add it straight up. Oops. And the exponents stay the same. So it comes out to 8703.23 times 10 to the 2nd. Okay. When we are doing numbers like these, we typically will want to put it back into correct scientific notation. So to put it back into correct scientific notation, I would be moving this decimal 3 times, okay, which means I need to add 3 places over here. So the number becomes 8.7 times 10 to the 5th, which, if you remember, is the same number we got earlier. You could have the rest of these digits out there and say 8.70323, but really, because this number only goes out to one decimal place and it only has 2 sig figs, we would want our answer only to have 2 sig figs. Let's look at the multiplication and division example. When you are doing multiplication and division, multiplication, you add up the powers. So if I'm just handling the top here, I have 10 to the 8th and 10 to the 2nd. That becomes times 10 to the 10th, 8 plus 2. And I just multiply these numbers. So I have 15 to the 10 times 10 to the 10th. At this point, I'm not going to worry that this is incorrect scientific notation. I know that I will fix that at the end. So then that is going to be divided by this number, 5 times 10 to the 4th. When you're dividing numbers and exponents in scientific notation, you subtract them. So I have 15 divided by 5, which is 3, times 10 to the 10 minus 4, which gives me 6. So 3 times 10 to the 6th would be my final answer there. And you can always check this on your calculator. If you know how to plug it into your calculator, it works exactly the same. And if you're curious about how powerful scientific notation is and what a difference that power of 10 makes, I highly encourage you guys to check out H.T. Twins' Scale of the Universe. Here you can start at 10 to the 0.0, which is on the order of magnitude of a human or a beach ball. If you go a little bit bigger, okay, or zoom in, sorry, to get a little bit smaller, at 10 to the negative 3, at the size of a millimeter, we're looking at the thickness of a piece of paper or a dust mite, smaller than an LCD pixel. Okay. If we go even smaller, now we're at 10 to the negative 6. That's the wavelength of violet light. That's the size of the largest virus in existence. Let's go the other direction. Okay. Let's go out until we're at 1,000 meters, or 10 to the 3rd. That's the size of Hoover Dam, about the size of the Eiffel Tower. The Washington Monument looks small in this scale. Okay, let's go out even farther. Oops, too far. Okay, at 10 to the 4.6, you can see that down here. That's the size of a neutron star, or Rhode Island. When we get up to 10 to the 7th, that's on the order of the size of Earth, or Titan, or Mercury, or Mars. These numbers start changing very rapidly. At 10 to the 9th, we're the size of stars. At 10 to the 14th, we're at the size of nebulas. And the farther out we go, the bigger the difference is, the bigger the nebulas get, until we're at the size of galaxies and constellations. You can see the Milky Way galaxy here at 10 to the 21 meters. So scientific notation is super powerful, very convenient when we're talking about either these very large things, or if we zoom all the way back in, these very small things. Until we get down to a helium nucleus at 10 to the negative 14.